Hello and welcome to Math Ketchup. In this video, we'll be looking at simplifying algebraic expressions. These are examples taken from our workbook, Algebra Foundations, which you can find on Amazon. If you're finding our videos helpful, don't forget to like and subscribe for more tutorials and worked examples. Let's get started. All right, our first example at level 1 here is simply collecting like terms. We can see in our example that we have 4 terms, as terms are separated by addition and subtraction signs. I'm going to collect our like terms, meaning I'm going to move my x's to the front and then have my y's follow behind. This allows us to collect like terms. Remember, our variables are treated like objects. So if I have 4 x's and I want to subtract 2 x's, I can do that. I have 2 x's left over. In the same way, if I have 1 y and I want to add 3 y's, I now have 4 y's. Now, our x's and our y's are different objects, if you want to call them that. We cannot combine an x and a y. We can't put them together. So our final simplification is simply 2x plus 4y. Just as an aside, it's important to remember that the exponent on our variables matters. If we had seen this, we cannot combine these. X squared is not the same as x. They are different objects. So therefore, they cannot be combined and they would have to stay that way. X squared is not the same object as x. All right, for level 2, we have an example where we are multiplying variables together, and these variables have different exponents on them. They do have the same base, but the exponent is different. So we have n cubed multiplied by n to the minus 2 multiplied by n. If there is no exponent on the variable, then we know that it is simply a 1, n to the power of 1. Now there's no addition or subtraction here, so we don't need to worry about like terms. In order to simplify this, we are going to use one of our exponent rules. The exponent rule that we are going to use in this case is the product rule. Now the product rule says that if you have 2 powers with the same base, such as a to the power of m multiplied by a to the power of n, you can just write that as the base, which in this case is a, to the power of m plus n. Now, it doesn't matter if you're multiplying 2 things or 3 things or 4 things, the rule stays the same. So if I go back to our example, I have the same base and I'm multiplying. So I'm just going to rewrite my base and I'm going to add the exponents together. In this case, it's 3 plus negative 2 plus 1. 3 plus negative 2 is 1. 1 plus 1 is 2. So our final exponent on our n is n squared, and that is our simplified form. Okay, for level 3, we're looking at something a little bit more complicated here, and we are going to use exponent rules again. We don't have any addition or subtraction, so we're not worried about like terms. We're just going to simply apply the exponent rules that help us to simplify, as that is our goal here. In this case, I would look at the numerator and the denominator separately. So let's look at the numerator first and see if we can simplify it. In this case, it looks like it cannot be simplified. We have a to the power of 3 over 2 times b squared. They're different bases. We can't combine the exponents, so I think we are stuck there. But let's see what we can do with the denominator. Our denominator has a power where there's an exponent outside of the brackets. Well, we need to go back to our exponent rules again and see what might help us. So if I go back and look at my exponent rules, I'm going to find a rule called the power of a power rule. Okay. What that rule says is that if you have a power, such as a to the power of m, and you raise that to another power, you can simply multiply the exponents together. Now, ours looks a little bit different as we have two variables inside our brackets. We have an a, there's no exponent on it, so we know there's a 1, and b to the power of 2, all raised to the power of a half. Now, the power of a power rule would be easy if it was just one variable inside. But because there's two variables inside, we need to have that 1/2 apply to the a and to the b. So we just apply the power of a power rule twice. So our a becomes a to the power of 1 multiplied by 1/2, and our b, which was squared, that 2 gets multiplied by 1/2, giving us a to the power of 1/2, and b, 2 times 1/2 is just 1. Let's rewrite our original question with our simplified denominator. A to the power of 3 over 2. B squared was our numerator. Our denominator is a to the 1/2, b to the power of 1. Now this might look familiar. Previously, we were multiplying powers with the same base, where we added the exponents. Now we are dividing powers of the same base. Well, just like the product rule, we also have a quotient rule. And the quotient rule says that if you're dividing powers with the same base, such as a to the power of m over a to the power of n, we can simply keep the same base and subtract the exponents. So if we look at our example now, a to the power of 3 over 2 divided by a to the power of 1/2 means we can just subtract the exponents. The b is going to do the same thing. B to the power of 2, subtract the 1 from the b on the bottom. 3 over 2 minus 1/2 is just 1, and 2 minus 1 is also just 1. So we are left with our most simplified form of a times b. Okay, that brings us to the end of this video. Once again, if you found this useful, please feel free to like and subscribe so you can get more content from us, and it helps us out a lot as well. We'll see you in the next video.